So today we're going to talk about the time series decomposition project. What is time series decomposition? Time series decomposition is the statistical method used to break down time series dataset into fundamental components, trend, seasonality, and residual or noise. This process helps in understanding underlying pattern and relationship within the data, facilitating forecasting, anomaly detection, and decision making. How does time series decomposition work? First one is identifying pattern. We can visually examine the time series plot to recognize trends, seasonal patterns, or irregular fluctuation. Separating trend and seasonality, we can apply decomposition method to isolate trend and seasonality components. And the last one is modeling the residual component. We can analyze the remaining data portion representing random variation or irregularities. The next one is parameter tuning. Decomposition method. We can select between additive or multiplicative decomposition. Seasonal period. We can determine the seasonal period capturing underlying seasonalities. Trend model. Choose trend model type and adjust parameters like degree or smoothing factor. And the last one is seasonal model. We can select additive or multiplicative model and fine-tune parameters. Next is the applications. Time series decomposition file application in various fields, including forecasting, can enable more accurate prediction by modeling trend and seasonality separately. Anomaly detection facilitate early detection of anomaly by isolating residual fluctuations. Exploratory data analysis can provide insight into data structure and relationships. And the last one, model evaluation, can enable detailed evaluation and validation of forecasting models. Next is the datasets of this project. The datasets used in this analysis contain daily temperature data of major cities worldwide. Source from Kaggle. It provides information on regions, countries, states, cities, date, and average temperatures. Dataset before preprocess with time series decomposition. Before preprocessing, the dataset undergoes filtering to select data from specific regions and cities. New attributes are generated, including date time from existing date attribute. Nominal attributes are converted to date format, and average temperature are aggregated. The datasets after preprocess with time series decomposition. After preprocessing, the dataset average temperature data is decomposed into trend, seasonal, and residual components. This decomposition provides insight into long-term patterns, seasonal fluctuations, and residual noise. The evaluation of time series decomposition technique. The evaluation involves comparing real average temperature data with forecast values generated using decompositions. Performance metrics such as RMSE, absolute error, and relative error are calculated to assess accuracy and effectiveness. We will show the predicting with and without the time series decompositions. Predicting the average temperature without using time series decomposition. You will see that RMSE is approximately 14.941. Absolute error is average around 13.613, and relative error is approximately 20.04%. Forecasting without decomposition results in higher forecasting errors, with notable increase in RMSE, absolute error, and relative error compared to decompositions. This is the result of predicting the average temperature without using time series decompositions. The next one is predicting the average temperature with time series decomposition. You can see that IMSE is approximately 7.969 and absolute error is average around 7.504 and relative error is approximately 11.40%. Forecasting with decomposition indicate moderate accuracies, as evident by lower IMSE and error compared to non-decomposition methods. This is the result of the predicting the average temperature with time series decompositions. Next, let's demonstrate the time series decomposition project. So we will start with the no decompositions. First, we get the data and we filter example to be the county and the city that we want. And then I generate attribute to be the date time for my data. And I change nominal data to be the date and aggregate the average temperature. Next, I set the date time to be the target ID. And this is my decomposition. It is the function and seasonal component for cat operator that I set the decomposition method to be no decomposition. And then I forecast it and generate attribute datetime again to compare datetime of the forecast average temperature and the real average temperature. Next, I join it to compare the average temperature and then I select the attribute that I don't want and I set the target to be average temperature and perform it. You will see that it have the warning that is the bug of the RapidMiner and I can fix it. Then I run it. This is the result of the forecast of average temperature with no decompositions. And this is the performance vector. Next is the time series decomposition with the classic decomposition. The first thing I do is the same like the no decomposition, but I change the function and seasonal component for cat add the decomposition method to be the classic decompositions. And then I forecast it. And I compare it with the join and get the performance. Then I run it. And this is the result of the forecast of average temperature with the classic decompositions. And this is the performance vector of this result. The advantage of the time series decomposition. Advantage include enhanced understanding, improved forecasting, anomaly detection, and detailed model evaluation. However, this advantage includes sensitivity to trend change, outlier sensitivity, and limitation in providing exact predictions. Next, I will compare the time series decomposition with the autogressive integrated moving average or ARIMA model. The ARIMA model will predict future value based on past data and analyzing autocorrelation and differences. And the time series decomposition will separate data into components for insights and simpler interpretation and anomaly detections. The time series decomposition offers a simpler interpretation compared to the ARIMA model and facilitate model evaluation. However, it may struggle with outlier sensitivity and trend change over time compared to ARIMA. This is the reference of the time series decomposition project. Thank you for your attention. If you have any question, feel free to ask me. Goodbye.